In 1915, Einstein's theory hinted at more than planets. It unlocked black hole history. I remember the moment my love for history and space collided. In a quiet library corner, I picked up a book expecting stories of inventors, but found something far bigger, a tale that stretched from ancient questions to the edge of the universe. It was the story of black holes, an idea born not from telescopes, but from a simple, daring question centuries ago. Science, I realized, is a grand adventure. Each discovery a clue in a cosmic mystery built on the work of those before us. The first black hole theorists couldn't see them, but their curiosity planted seeds that grew for generations. These early thinkers were explorers, venturing to the edge of the known with imagination and reason. Their story showed me that the greatest journeys often begin in the pages of history, connecting us to the past. To understand the future of space, we must look back, because today's questions echo those asked long ago. So let's travel back and follow the clues that unlocked one of the universe's biggest secrets. Our story begins over 2 centuries ago with John Michell, a brilliant English scientist. In 1783, Michell wondered, what if a star was so massive and dense that its gravity could trap even light? He called these dark stars. He imagined that if you packed enough mass into a tiny space, the escape velocity would exceed the speed of light, making the star invisible. Michell's leap of imagination was the first hint of what we now call a black hole. But in the 18th century, technology couldn't test his theory. Telescopes saw only what shone, not what vanished. Michell's idea faded into obscurity, a brilliant speculation ahead of its time. The world needed a new way to understand gravity before dark stars could become real science. That breakthrough would come over a century later, from a revolutionary mind. In 1915, Albert Einstein changed everything with his theory of general relativity. He showed that gravity isn't just a force, it's the warping of space and time by mass. Imagine a bowling ball on a trampoline. Massive objects bend the fabric, pulling others in. Einstein's equations suggested that if something was dense enough, it would create a bottomless pit in space-time, a region from which nothing, not even light, could escape. Even Einstein doubted this strange implication, but the math was clear. Soon after, Karl Schwarzschild, serving in World War I, solved Einstein's equations and described the first mathematical black hole. He calculated the Schwarzschild radius. The size an object must be crushed to become a black hole. For our sun, that's just 6 kilometers across. Schwarzschild's work gave black holes a concrete form, a point of no return, the event horizon. Though he died soon after, his equations laid the foundation for everything we know about black holes. For decades, black holes remained theory until the 1960s, when astronomers spotted quasars, tiny, bright objects pouring out more energy than galaxies. What could power them? The answer: supermassive black holes devouring matter at galactic centers. As gas and stars spiral in, they form a superheated disk, glowing with unimaginable brightness. The black hole itself is dark, but its feeding frenzy lights up the universe. This was the first real evidence for black holes no longer just a dark spot but a cosmic engine. Soon, astronomers found stars orbiting invisible companions and X-rays from matter vanishing into darkness. All clues pointed to one thing: black holes are real, and they're everywhere. What began as a wild idea was now central to astrophysics. The hunt for these cosmic monsters had truly begun. For centuries, black holes were invisible, proven only by their effects. But in 2019, the Event Horizon Telescope, a network spanning the globe, captured the first image of a black hole in galaxy M87. The photo revealed a glowing ring of light, an accretion disk, warped around a shadow of pure darkness, the event horizon. It was a breathtaking confirmation of Einstein's theory, matching predictions exactly. This image connected centuries of ideas: Michell's dark stars, Einstein's equations, Schwarzschild's math, and modern technology. Thousands of scientists worked together to make it happen, a triumph of curiosity and collaboration. That glowing ring is more than a picture. It's a symbol of our drive to explore the unknown. From a library book to a planet-sized telescope, every step mattered. Which part of this journey amazes you most? Share your wonder, and let's keep exploring. If you found this historical journey fascinating, take a moment to hit that like button and subscribe to join our growing community of history enthusiasts. Share your thoughts in the comments below and let me know which historical era you'd like us to explore next. Your feedback shapes our future content. Don't forget to activate the notification bell to stay updated on our weekly historical deep dives. Thanks for being part of our historical adventure. See you in our next exploration through time. Copyright 2025 Mellori Hope Carrington trademark, all rights reserved.